They call it a Type 6 civilization. It's the final level of a futuristic scale that measures how advanced a civilization is. It's called the Kardashev scale. But who made this scale and why? And yeah, how does our human civilization rank on it? We owe the scale to Nikolai Kardashev. He was an astrophysicist and one of the best radio astronomers of the past century. He got interested in astronomy at an early age. The future scientist worked hard and earned his PhD in 1965. Then he published an academic paper that introduced the scale with his name. Fellow astronomers got interested and expanded Kardashev's scale. At first, the scale only had 3 types of civilizations. One of the people that modified the scale was Carl Sagan, the famous American science writer. The key word to understanding the Kardashev scale is energy. Possible societies from other planets are measured by the amount of energy their technology uses. The more energy a civilization is able to harness, the more powerful the signal it can send. This means we would be able to detect them first. The principle is quite simple. Imagine you were stranded on a desert island. If you manage to light a fire, there's a high chance a plane or a ship will spot you. But imagine you had a signal flare. It would go high in the air, so it would be easier for the search party to find you. Kardashev's scale measured transmission distance in theory. Think of this radio signal as the flare I've mentioned. The most technologically advanced civilization would be able to send the signal the furthest. The more energy a proposed civilization had, the more powerful it was. The famous astronomer decided to rank civilizations in this way. A Type 1 civilization is also called a planetary civilization. A suitable name, as this civilization only has the capacity to harness energy from its home planet. This includes the energy that reaches the planet, such as sunlight. Another form of energy is one the civilization can produce itself. Think of power plants, wind farms, and hydro plants. Sounds a lot like Earth, doesn't it? Yeah, not quite. You see, we are not even a proper Type 1 civilization. Carl Sagan ranked Earth as 0.72, not a full 1. In comes Michio Kaku to explain. This theoretical physicist is one of the best-known popularizers of science today. In his mind, a Type 1 civilization should be able to control the elements, such as volcanic eruptions and the weather. This also includes those nasty shakings of the Earth. Humanity can't even predict these, let alone control them. Ocean cities are another example of technological achievement. For now, underwater cities are something that we can only see in movies. That's why Michio Kaku believes that Earth won't reach Type 1 civilization for at least a century or two. This stage in the development of civilization includes the complete use of resources on the planet, from the energy of the sun to the minerals hidden underground. Then this society would be kinda ready to upgrade. A Type 2 civilization would expand its search for energy beyond the home planet. That's why this type is called an interplanetary civilization. In terms of scale, this would mean using 10 billion times more energy than a Type 1 society. Sagan made this calculation. It would involve more than collecting the sun's energy using solar panels. Yes, I'm talking about going directly to the source. In theory, the best way to achieve this is to use a Dyson sphere. This is an engineering project on a massive scale. The idea is to encircle a star, like our sun, with orbiting platforms that would form a sphere. The goal is to harness the star's energy and use the platforms as living space. Sounds out of this world, right? Well, that's because it is. The megastructure got its name from the American theoretical physicist Freeman Dyson, who first proposed it back in the 60s. He believed that the sphere would be the way possible extraterrestrial civilization would generate energy. If we spot one in outer space, there is definitely an advanced society behind it. For humans, the Dyson sphere might become a reality in 1 or 2,000 years. That's how far we are from becoming a fully fledged Type 2 civilization. That's a long time. I mean, 1,000 years ago, we were in the Viking Age, nowhere near the world we live in today. But wait till you hear how long it would take us to reach Type 3, a full 100,000 years. This civilization would go beyond its home and other planets. It would master entire galaxies. This far into the future, who knows if humanity would still exist? At least in the format we know of it today, robots would probably be constructing Dyson spheres across faraway galaxies. Are you tired of getting stuck in traffic jams on your way to work every day? The laws of physics state that the fastest you can get there is at the speed of light. To us, this speed is astounding. But for future civilizations, this would be slow. They would need to warp space and time to go faster. Yes, exactly like the warp drive from Star Trek. Or they could develop wormhole teleportation. We are barely a Type 1 civilization, so we can only guess what a new technology a Type 3 will use to travel across the universe. This advanced society would probably be able to extract energy from black holes. Another possibility is that they could manipulate molecules. They would create new materials out of nothing. If such a powerful society exists, humanity should not hope to come in contact with them. So far, we are technologically inferior. Kardashev thought of Type 3 as the most advanced civilization possible. He didn't feel the need to further develop his theory. But other science enthusiasts didn't stop there. They expanded the scale with extra types. In the new scale, a Type 4 would harness the energy of the entire universe. They wouldn't need to live on a planet, but would inhabit black holes. The energy sources they would use are unimaginable to us. These societies would be so advanced that they would use laws of physics humans haven't discovered yet. So, is there anything left for a Type 5 civilization after Type 4 mastered the whole universe? Yep. Because who said there had to be just one universe? Their society would source power from multiple universes, that is, multiverses. At Type 6, a civilization wouldn't have to worry about energy. It would be so advanced that it could create universes. These beings would probably be able to control space and time. They would have the status of a deity. At some point, this civilization would probably become one entity, a supreme single mind that would control all existence. It would be the only one to understand what a more advanced type of civilization would look like. We Earthlings don't stand a chance of grasping the concept. But it's not all bad news for the inhabitants of the blue planet. We have the possibility to move up the scale. Kardashev made the scale to measure civilizations beyond Earth. He gave our planet only as a starting point. We are advancing slowly, but every new power plant humans build is a step closer to a proper Type 1. Scientists estimate that every time we increase our total energy supply by a quarter, we advance 0.01% on the scale. This occurs every 5 years or so. Not a huge push forward, but we're getting there. The key to reaching Type 1 and beyond is renewable energy. Every now and then, scientists discover a new source of energy. Geothermal energy and offshore wind power are just a couple of examples. Each time we find a new way to power our world, we get a step closer to a planetary civilization. So far, the energy of the sun seems the most promising. There are already solar panels at the International Space Station.
Don't hold your breath, but we're very close to hitting a major milestone in human history. Some scientists say the next couple of centuries will be a make-or-break situation for us. Will we be a measly Type 0 civilization forever? Or will we blast off into the stars like the boss-level beings we are? Don't know what a Type 0 civilization is? Let me explain. As our species gets bigger and smarter, our energy needs go through the roof. And that's not just because we all want to keep our hair dryers running, but also because all our fancy machines need energy too. Our transportation devices, factories, and communication tools. The Kardashev scale is useful in measuring how advanced a civilization is, based on how much energy they've got. So far, there are 7 theoretical levels a civilization can be at, according to most specialists. I'll spare you the Google search. Some scientists have estimated that humans are at a mere level of 0.72. We're not even a Type 1 yet? The scale was invented by a scientist named Nikolai Kardashev in 1964. He created it to help look for signs of life in space through the signals it might give off. His scale has 3 main levels that show the amount of energy a civilization has access to. Over the years, other scientists added many more levels, which are even more advanced. This scale not only shows energy access, but also how much knowledge a civilization has. A Type 1 designation is when a species can gather and store all the energy from a nearby star to power its growing population. This means we need to increase our energy production 100,000 times to reach this status. Some scientists say we could reach Type 1 in 100 to 200 years. But for that, we would need to harness all the energy on Earth. It sounds amazing, but compared to what advanced societies with higher rankings can do, this is just a basic level of control. The next level of civilization is called Type 2. They can control their whole nearby star and use all of its energy. One way we might be able to do this one day is by building something called a Dyson sphere. I'll spare you the technical details, but it's like a giant ball that goes around a star and collects all its energy, then sends it back to the planet it came from. With this much energy, nothing in science could destroy a Type 2 civilization. If humans became a Type 2, and a moon-sized object was headed toward Earth, we could just vaporize it, or even move Jupiter to block it. Type 3 civilizations become energy experts and can travel through the galaxy. Humans who evolve into this type may look very different from us, like machines with both biological and robotic parts. They might even look down on regular humans. Who knows? It's unlikely you'll make friends with a Type 3 person, that's what I'm saying. These humans might also have colonies of robots that can replicate and spread across the galaxy. But there are limits to their travel because of the laws of physics, or at least those that we know today. That is, unless they invent a new way to travel faster than light or teleport through wormholes, which are currently only theories. Kardashev believed that a Type 4 civilization could not exist. That's the reason why he did not go beyond a Type 3 on his original scale. He thought Type 3 was the limit any species could achieve. Some people agree with him, but others think there could be even higher levels of civilization. Type 4 civilizations and up were theoreticized by other scientists. A Type 4, for instance, would be able to harness all the energy in the universe and even live inside black holes. This kind of technology would need to use laws of physics that we don't understand yet, and might not even have the resources to discover at this point. Type 5 is even more mind-boggling. This would be a level where beings have the power to control the universe itself. It would also exist in a world with multiple parallel universes. Humans are far from ever reaching this level, but if we take care of our planet and each other, who's to say it can't be possible one day? These types of civilizations would have the ability to travel to different universes and even be able to create our own. They have control over reality, and their population would be so large, it would be, in theory at least, indestructible. A Type 6 civilization is even more powerful. They would have the means not only to create and travel to other universes, but also to control the basic functioning rules of these worlds. They would exist in a lot of different universes at the same time, and they could affect all the laws of physics as we know them. They also exist in many different versions of space and time, with different pasts and futures. A civilization that is categorized as a Type 7 or K7 is capable of traveling and controlling the entire omniverse. The omniverse is a term that refers to every universe, dimension, and reality that exists. This level of power is thought to come from an individual rather than a civilization, as the civilization would have merged into one entity that is all-knowing, all-powerful, and present everywhere. Okay, let's slow down for a bit. Before we reach all these incredible levels, we at least need to become level 1, right? But what would that take? Right now, humans are not advanced enough to be considered a Type 1 civilization because we only use a few sources of energy, like wood, coal, and oil. But there are many other sources out there that we haven't discovered or used yet. We'd need to rely solely on renewable sources, like wind, sun, and water for our energy needs. This energy would be so accessible that you might not have to pay for your power bill anymore. In a Type 1 civilization, energy would be as essential as air. One strategy would be for us to turn natural disasters into something positive. For example, we can use tsunamis to make electricity. We could rely less on construction work and use earthquakes to help us change the land. By controlling the planet's energy sources, we could also control the weather. For instance, if a certain place would be experiencing a drought, we could just send rain clouds to bring it back to life. If we become a Type 1 civilization, we might be able to balance the amount of carbon in the atmosphere and end up controlling our planet's temperature. This means that natural disasters will become easier to predict and less damaging. Additionally, we might even be able to live in places we never thought possible, like underwater, on top of mountains where it's freezing, or in the desert. So how close are we to this level upgrade? A recent study looked at the different ways we get energy, like from fossil fuels and renewable sources. Problem is that each way of getting energy has its limitations. For some, we have limited materials. For others, at least for the time being, the costs are too high. So, the team behind this study took a careful approach to make precise calculations. They found that we can reach a high energy level, but it won't happen until the year 2371. This study shows just one way we can become an advanced civilization, but it's also possible that we'll get there in a completely different way. Also, let's not forget, the first rule in becoming an advanced technology is to not become extinct. I know that sounds a bit redundant, but in our quest to harness all the energy this planet has to offer, we also need to protect it to the best of our abilities. Until we manage to travel to the edges of the universe, Earth is still the only place we call home.
A space settlement floating out there in the cosmos. It's not sci-fi. But, as always, there is a catch. Look at this tiny deserted asteroid. It may look lonely and barren, but if you peek inside, you'll see life blooming inside of it. These days, many people now live right inside these asteroids. It's not sci-fi. According to researchers, we might be able to create futuristic cities the size of Manhattan on gigantic space rocks. Of course, there's a catch. The asteroid we choose as our base has got to be at least 1,000 feet wide. Though it's weird why life is inside this asteroid and not on its surface. You see, we can't really live right on asteroids. That's because we're not the little prince who indeed lived on an asteroid, according to the plot, but because there's too little gravity and too much radiation for us to handle if we chill outside. There are possible theoretical ways to stay on the surface, but it's going to be extravagant. So the only option is living inside asteroids. Nothing screams wildly theoretical like building an asteroid city. Living in space without any gravity isn't as romantic as it sounds. Researchers show that when people spend too much time in zero gravity, things start getting weird. Their eyeballs pop out, retinas detach, muscles shrink, and bones become as fragile as a potato chip. But imagine this, a space settlement floating out there in the cosmos. If you've watched enough sci-fi, you'd picture a massive structure spinning round and round. It spins to create gravity for all the lucky folks living inside. There's an actual prototype of this wizardry, the O'Neill cylinder. This device is named after physicist Gerard O'Neill, who came up with the idea for NASA in the 70s. Now, there isn't a ton of data on this, but humans need roughly 1/3 of Earth's gravity to function properly. An O'Neill cylinder may not be able to generate massive amounts of gravity, But the genius behind it, Mr. O'Neill himself, designed them to spin around their long axis. This device creates a gravity-like force called centrifugal force. So, if we ever get to use that, we'll be living happily on the inner surface of the cylinder, feeling pulled downward away from the center. But, as always, there is a catch. When the team crunched the numbers, they realized that the asteroids would break apart way before they could reach the speeds necessary to keep us grounded. And to make matters worse, most of these asteroids were more like loosely assembled piles of rock than a solid chunk. The small ones, like less than 6 miles across, are a mix of sand, pebbles, rocks, and boulders. They're all held together by the weak force of their own gravity. If you were to spin one of these asteroid buddies, all those parts would go flying off into space. Not cool. However, scientists didn't give up and they elaborated on the idea. They needed to find a way to keep the asteroids together. They played around with different ideas and they produced something crazy. Now, if you were to carry all your personal belongings every day right in your hands, at some point, the situation would be out of your control. You'd have to collect all your stuff from the floor. But you're smart and you carry a bag, right? Well, it seems that if we want to control an asteroid, all we need is a ginormous bag. But not just any bag, a massive, flexible, and super lightweight mesh bag made from teeny-tiny carbon nanofibers. These fibers are like tubes that are only a few atoms wide, but boy are they strong. So once we've got this cylinder-shaped bag all set up, we can start slowly spinning the asteroid using rocket motors deep within the rubble. And as it spins faster and faster, it'll start flinging all those pebbles, rocks, and boulders. And guess what? The carbon nanowire webbing is going to go flying out with them. This bag will be expanding and expanding until it reaches its absolute limit. And then the rubble inside slams into the now super tight webbing. It's like a crazy explosion of debris compacting together to create this massive hollow cylinder made entirely of concrete. Once all the dust settles, you can build entire towns, cities, parks, and even farmland on the inside of the cylinder. This is like something straight out of O'Neill's designs. You can even enclose the whole inner surface with a transparent roof. Outside of this incredible living area, you've got these thick concrete walls that are like superhero shields protecting against radiation. So not only do you have this space to live in, but you're also super safe from any harmful stuff outside. We still don't have this magic bag, as those magic carbon nanowires aren't mass-produced yet. But scientists claim that, according to the laws of physics, a tiny asteroid, like a few football fields put together, can be transformed into 22 square miles of living space. As of now, about 1.5 million people are living in Manhattan, and there are like tens of thousands of asteroids just hanging around in our solar system. You do the math. Seems like everyone will have a sweet spot to crash in space. Building a city in space is no easy feat. The main challenge still is to create a self-sustaining closed system that can keep going for the long haul. You see, cities on Earth rely on a much larger area to survive than just their own boundaries. But in space, the farther away from external resources a space city is, the more it needs to close its loops for oxygen, water, and food. Take the ISS, for example. It's about 40% efficient in recycling oxygen, but even then, its CO2 levels are always sky high. NASA is on the case, though, trying to figure out how to magically turn that CO2 back into oxygen. Once we've tackled the basics, like protecting ourselves from radiation, dealing with pesky gravity, and finding some air to breathe, it's time to get creative in space. Enter 3D printing and rocket engines, the dynamic duo that will pave the way for space settlements. With 3D printing, we can kiss goodbye to relying on Earth for spare parts. We'll simply whip them up locally, cutting out the middleman. We can even use 3D printers to whip up a delicious pizza in a couple of minutes. Of course, we'll need some fresh ingredients, but your dinner might just be a push button away in space. To truly thrive out there, we'll need to tap into the riches of asteroids. These celestial treasures are bursting with raw materials, perfect for creating solar arrays, building materials for our colonies, and so much more. And let's not forget about comets. These icy wonders are like cosmic water fountains, providing us with precious H2O for drinking, bathing, and even shielding ourselves from radiation. Plus, we can use that water to produce hydrogen and oxygen for rocket fuel and fuel cells. So, let's say we pull this off. Can you imagine people living or born in space might end up being different from you and me? Like if humans can have babies up there, these space colonies might develop some cool cultures. They might even come up with their own languages, and get this, they could even evolve new physical traits. It's wild to think that just after 300 years, a colony of 2,000 people could look and act so differently from us. They might have different hair textures, skin types, and even be taller or more slender to deal with that low-gravity situation. We might even develop new organs to protect us from cosmic rays, or we'll have gill-like structures to breathe carbon dioxide. Hey, I know, it sounds crazy, but these scientists are working on developing these carbon nanotubes as we speak. So maybe one day we'll be living it up on our very own asteroid crib. It might seem like asteroid cities are just too far-fetched, but let's take a trip back in time for a moment. In 1900, no one had ever flown in an airplane, but today, thousands of people are zooming through the sky, comfortably seated in chairs, traveling at hundreds of miles an hour high above the ground, unaware that their luggage is on another plane going to a different destination. Ah well. So how alone are we in our galaxy? Crickets. Yep, we're mostly alone out here. But are there other civilizations lurking somewhere out there in the depths of the Milky Way? Could they possibly have evil intentions and be a threat to us? Hey, like we need more threats. Well, hey, let's have some fun with this. Some theorists reviewed humans' history and past actions toward one another. No miscongeniality awards there. And assuming they were somehow like us, used this to calculate the probability of space invaders. They determined that there could be 4 evil civilizations in our galaxy. The 4 could be eager for intergalactic domination, or maybe just for a good game of dominoes. They could be highly advanced in technology, or they've only just invented an evil version of game consoles. To understand how advanced these cultures could be and what to expect, there is a way to define their threat levels. A method called the Kardashev scale analyzes intergalactic nations' possible abilities. With 3 different levels, it reviews the amount of energy a civilization could take from their star, indicating their tech level. This only includes those that have reached interstellar communication. So any other beings out there using, let's say, space pigeons will of course be excluded. Type 1 shows that they can harness the energy from the sun, but only from what is received within their own planet, like solar power panels. Type 2 is where they can use the energy directly from the sun, like through a Dyson sphere. It's used to harness all of the sun's energy, having been built entirely around it. And lastly, Type 3, where civilization can use all elements provided by the galaxy, with the power to not only harness the energy from stars, but also black holes, even the central supermassive one. These levels are important to assess how advanced civilizations could be out there. The Milky Way is estimated to be around 13.6 billion years old. Modern humans have only been around for the last 200,000 years, and we're only a Type 1. It's scary to imagine the time other beings have had to develop. We're considered a bit of a late bloomer in comparison. Earth is, shall we say, late to the party because we're located on the outer arms of the galaxy. Mathematicians posit that more centralized star systems have had more time to progress. Now, with that in mind, how common would other intelligent beings be in the galaxy? With all the life-ending events Earth has survived, it's a miracle to have a planet like ours, and that we would be unique. Or are we? Well, there are 100 trillion stars in our galaxy, and there are up to 200 billion planets, with an estimated 300,000 exoplanets capable of sustaining the kind of life we know about. From those habitable planets, how could we tell which ones have other beings eager to send us an email? No one's had the time to individually count, of course. The Drake equation can give us some rough numbers if we take averages of a few key factors. It breaks down the criteria of how many planets with life are intelligent enough to make communication. The numbers are huge, considering how many stars might have planets. And from there, we distill it down further to those within the habitable zone in the solar system. This zone is called the Goldilocks zone, as it's not too far from the Sun and not too close to it. It's just right. We reduce the numbers even further by calculating which of those habitable planets will then be able to support life. And from those random places, the equation takes the probability of how many intelligent beings will be and if they are intelligent enough to communicate. The criteria is complicated, and so it's not an easy equation to explain. But from its estimate, there could be up to 100 million planets with intelligent civilizations. But just like with Earth's history or struggles, these civilizations may also have their own challenges. World-ending events should be thrown into the equation, like asteroids, solar flares, supervolcanoes, and supernova. They could also destroy themselves through technology, like AI dominance or nanotech, or by affecting their own ecosystems and running out of resources, or by just acting stupidly. If we take these into the equation, the remaining living civilizations could be around 15,000. But what could they possibly want from humans? We do have an abundance of rare earth materials that could be of value, ready to be harvested and easily collected. Besides an appealing vast amount of water they could suck dry, hydrogen is a required element of rocket fuels. Though these things aren't exactly rare in the galaxy and could be harvested easier from other closer solar systems or asteroids. Our technology might be intriguing to them. Our range of innovations on Earth, invented while being isolated in separate countries, help provide different technology paths around the world. Other civilizations could have followed a completely different route and didn't learn the importance of many things we have here on Earth, like karaoke. The same goes for applied sciences, where they may have evolved in different atmospheres with different elements. Their science would be mainly affected by that, and ours would provide them with more knowledge. Then, there's one of the rarest things in the galaxy, that Earth can support life. This would be very useful for an intergalactic traveler, rather than going through the long process of terraforming an unlivable planet. Why not just take it? With a cozy outpost, it would be a lovely little holiday destination when they need some time off from conquering other civilizations. Fortunately, they wouldn't be interested in eating us, or probably wouldn't have an appetite for anything on Earth. They would need to have similar biochemistry and require the same enzymes to process the molecules we're built from. Whew! But the most likely thing they would want is to remove any competition. The biggest threat to them is anything that would provide a challenge to their domination. But before you get too frightened by these evil civilizations, this was based on human behavior. It's possible that any beings out there could lack or avoid many of our human emotions. For instance, their capacity for anger might be limited, or they could have evolved without it. They could come from a world with a history so different from ours that they could be overly trusting, making us the bad guys. But again, they may also lack empathy and other positive traits we have. Well, let's hope they only have our nice traits. Luckily, there's a big thing that separates us from everything else. The galaxy is huge, and it takes a very long time to go anywhere, even to our closest solar systems. The fastest thing we've sent into space is the Galileo probe, which travels up to 100,000 miles per hour. Even so, it would take 72,000 years to reach the closest star system, Alpha Centauri. Still, with a newly proposed laser-guided probe that could travel at 1/5 the speed of light, it would yet take up to 20 years to make that journey. On a larger scale, the Milky Way is over 105,700 light-years across. If a civilization was even capable of light speed, it would take them hundreds of thousands of years to travel from one end to the other. With a huge distance between the small number of civilizations, the only successful contact would be through advanced interstellar travel. But to achieve such a long journey, the greater the mass to be accelerated, the more energy is required, so it's not likely anything too large will be sent. But they could travel here very quickly in a small shuttle, using the ability to break cosmic speed laws. They may already be here, watching us closely, or just binge-watching Netflix. They would need very advanced technology, and the number of species obtaining this is theorized to be only 2 out of the 15,000. That means there's a 1/100% chance of evil civilizations capable of visiting us soon. If they do know we're here, and they want something from us, it's likely to take them thousands, if not millions of years to arrive. So, we've got plenty of time to relax. Time for more bright side.
Dozens of spacecraft and hundreds of probes take off from Earth and head for our planet's twin sister, Venus. It's about the same size as the Earth and has around 80% of our planet's mass. The temperatures here are too high for humans, and it doesn't have the air we're used to breathing. But we went there because scientists recently found traces of phosphine gas, which suggests that life might be there. Phosphine comes from various microbes and bacteria, so humanity goes on this journey to discover this life. With our technology, a flight to Venus would take 3.5 to 6.5 months, but we finally made it. Spaceships are landing on the planet, and when the first humans come to the surface, they see heat-scorched deserts, lava lakes, and geysers of poisonous acid. And that's it. Scientists miscalculated the radio telescope data. Phosphine never existed on Venus. So we're going back to the rockets, and we're getting ready for a longer trip across our galaxy. The scientists believe that there's at least 36 civilizations in the Milky Way that are similar to ours. They could be living organisms completely different from us. They may have different bodies, different eyes. They may walk and talk in a very different way than we do. But an advanced civilization has several criteria: technological progress and the use of developed communication between individuals. So, these civilizations must explore space, build cities, and be able to communicate with each other as independent species. Let's look at our galaxy and find these civilized worlds. So, the Milky Way is a spiral of 100,000 light years from side to side. If a star is born at one end of it in a super powerful blast, the light from that event won't even reach the other end until 100,000 years later. There's about 100 billion stars, and near each of them, there may be worlds similar to our solar system. Let's try to find these habitable worlds using giant sieves. First, we look for stars that have a lot of iron. Such stars burn at the perfect temperature for the development of life. And the iron in the star system will help form the cores of planets that will be home to another civilization. We sift the Milky Way through our sieve. We see that there are too many stars that fit the description, so we need another filter. Now let's find stars that look like the Sun in this pile. The star must be about 100 times larger than the Earth and 333,000 times heavier. An important criterion is the age of the star. When a star gets old, it begins to expand and turns into a red giant. At this time, it can absorb the planets around it. The life of such a star can end with a huge blast that destroys everything around it. So the star we're looking for must be relatively young. Let's use our sieve again. There's fewer stars, but still that's a lot. Now let's focus on the planets. They should be in the habitable zone of the star. Not too close to a star because then the temperature would be too high for life to be born. And not too far away. Then the planet would just be an ice block with nothing living on it. The temperature of the planet must allow the water to remain liquid. Another filter is the age of the candidate planet. It takes time for an advanced civilization to develop. Based on the experience of Earth, scientists believe that it takes at least 4.5 billion years for any life form to evolve to the human level. So we're looking for planets similar to Earth or older. We use our sieve one last time, and voila, we have 36 worlds where an advanced civilization is possible. Scientists conducted this study and published it in April 2020, based on these very criteria. All that's left is to discover these civilizations and make the first contact. We can detect such a civilization by using radio waves that come from it. Suppose there's a planet A with primitive living organisms on it. Millions of years of evolution, and they'll become a civilization with advanced technology. Radio waves will be the way they communicate. Then the whole planet will emit radio waves like a star emits light. And here on Earth, we'll be able to pick up this signal with antennas pointed into space. But there's a problem with the distance between the planets. For example, planet A is 1,000 light-years away from the Earth. When planet A starts emitting radio waves, these signals won't reach us until 10 centuries later. We learned to emit and receive radio waves in 1895. And if the civilization on planet A emitted a radio signal at the same time, we won't be able to pick up that signal until 2895. It'll be the same on planet A. We sent a message in the form of a radio signal into space in 1974. In this signal, we encoded our number system, human DNA, and information about our solar system. If there's an advanced civilization on planet A, they'll be able to receive this signal only in 2974, and we'd have to wait another millennium to get a response from them. Another problem with radio waves is that they don't look like a constant glow on the planet, but like a flare. Radio waves are only used at a certain stage of civilization. At first, it's the primary method of communication, but then we begin to use cell phones, cable TV, and fiber optics. And as technology advances further, our radio wave light begins to fade out. So we only have about 100 years of active radio use by civilization to find it. One day we caught a strange radio signal of an unknown origin. Its characteristics suggested that the signal was created artificially, perhaps by an outer space civilization or a passing starship. Further searches for this signal given no results, and this gave rise to many theories and arguments as to what it really was. It could have been a signal from Earth that reflected off a satellite flying through the sky, or it could have been the traces of a comet a few light years away. But let's assume it was a civilization from outer space, one of those 36 that probably exist. Now we need to make contact with them. So we throw our luggage into a rocket and head out in the direction of our suspected planet. Our rockets can fly at 17,600 miles per hour. That means a rocket could cross the entire United States in just 8 minutes. But even if an advanced civilization lived near our closest star, Proxima Centauri, it would take us about 73,000 years to get there. Even at the speed of light, it would take 4.2 years. So we need to solve the problem of space travel. Our scientists plan to reach about a quarter of the speed of light with a laser. A powerful laser beam from Earth will push a microscopic probe in the right direction. This probe could reach our destination in about 17 years. And in another 4 years, when the signal from it reaches Earth, we'll know if there's an advanced civilization. Another possibility for faster-than-light travel is the warp bubble spacecraft. The spacecraft would have to compress space in front of it and stretch it behind its tail. Then we'll be able to reach any point in the universe in literally a few seconds. But such travel remains a fantasy for us. Perhaps we can get to different corners of the universe through wormholes. They're shortcuts similar to tunnels, but there's one problem. These wormholes might be inside black holes. They're the most mysterious objects in the universe. They're so heavy that even light can't escape their trap. Our spaceships wouldn't stand the tension either. There's also a theory that Earth is unique because it was born under completely accidental circumstances. 4.5 billion years ago, our planet was a block of lava that began to cool and solidify. But its tranquility was broken by an asteroid the size of an entire planet flying by. The collision occurred at such an angle that the Earth was not completely destroyed, but part of the asteroid remained in our orbit. A heavy rock near our planet stabilized Earth's rotation, and the gravitational interaction with the giant debris caused our core to heat up. In addition, the asteroid brought a lot of water to Earth. Such a collision is extremely unlikely. It's like winning the lottery, many times in a row. But so far, we have no reason to believe life in outer space exists. Just as we have no reason to believe that there's no advanced civilizations in the universe, except for ours.
Let's talk about cyberpunk, a really cool genre of science fiction that started in the early 1980s. Its pioneer writers were really interested in how technology was changing society, especially with all the digital evolution happening at that time. One of the writers, Bruce Sterling, wrote an introduction to a book called Mirror Shades, which was like a guide to cyberpunk. He said that this genre is all about looking at technology in a new way, not just for science fiction writers, but for regular people too. It's like imagining a world where high-tech stuff and the cool underground culture mix together. The heroes of cyberpunk stories are mostly rebellious people who stand up against big companies and the boring mainstream. They believe in being unique and doing their own thing, even when the world tries to contain their efforts. These heroes are really good at taking things from popular culture and using them to express their own ideas and interests. They also know how to use computers to find out secret information and spread messages that go against the system. These days, cyberpunk themes are seen in more than just literature. You can find their influence in things like movies, video games, and even fashion. It does make you wonder though, could the future truly turn out to be what cyberpunk writers predicted? Truth is, all the cyberpunk literature is packed with mind-blowing technology that might just become a reality one day. Like augmented reality, for instance. Now this might sound far-fetched, but we're actually getting closer to experience AR in our daily lives. I mean, some companies are already offering such devices. Right now, they're mostly used for gaming and entertainment, but soon enough, we might use them for virtual training, education, and even shopping for a new car or checking out a house. Next up, smart clothes. In cyberpunk video games, people are rocking these stylish garments that not only look cool, but also offer some serious protection. We're not quite there yet, but smart clothes are becoming a thing in our world too. You've probably heard of smartwatches and fitness trackers, right? Well, imagine clothing that can monitor your body's movements, suggest healthy habits, and adjust your body temperature. Some fashion brands are already exploring this exciting field. Now let's dive into virtual reality. In one particular cyberpunk story, there's a feature where you can customize your own virtual reality experience. It's like stepping into someone else's shoes and reliving their memories. Now, VR is already pretty amazing in our world. We use it for medical purposes, gaming, and tourism. And here's something even cooler. Imagine being able to feel things in virtual reality. Yeah, it's called haptic technology, and it's being developed to make VR even more immersive. You could use it to control machines, learn in a virtual classroom, or even attend a concert with friends who are miles away. Last but not least, we have artificial intelligence. In a cyberpunk scenario, AI is everywhere, from brain analysis to taxis with intelligent controllers. Now, we might not have all that advanced AI just yet, but we're definitely making progress. You're probably familiar with all those virtual assistants featured on smartphones. Well, imagine them getting even smarter. AI is expected to be integrated into so many aspects of our lives, like fridges that can automatically order groceries when we're running low, self-driving cars, and delivery drones. And hey, AI is already helping companies suggest personalized content based on certain preferences. In the future, it might even help us find the perfect recipe for dinner or recommend the ideal cosmetic product just for us. Then, there's the potential for a brain-computer interface, or BCI for short. In a cyberpunk world, it's like a special connection between our brains and the internet that would allow people to virtually explore using just their minds. In the real world, scientists are already working on developing BCI systems. They can read the signals from our brains and turn them into commands. So instead of using a keyboard or a mouse, we might be able to control objects just by thinking. Right now, these BCI devices are being used in research settings, but someday they could be used to support people. They could help with regaining useful functions and improve rehabilitation. It doesn't stop there though. BCI could also help professionals like pilots and surgeons. It could make their natural skills even better and help them do their jobs with even more precision. But, there are also some things we need to be careful about when it comes to this cyberpunk technology. In the cyberpunk world, there are serious problems to consider. One of the concerns, for instance, is that if we rely too much on technology, it might start making decisions for us. We might become less skilled at day-to-day tasks because we let the machines do everything for us. That's why we should focus on using our own resources to make our own choices. Another thing we need to watch out for is protecting our information. All sorts of security breaches are already happening all over the world. We need to make sure we have strong measures in place to keep our information safe. Science and technology are moving at an incredible pace these days. It's hard to pinpoint what the future might look like, but you surely have some sort of scenario in mind. Maybe you envision a world where robots and AIs, controlled by a handful of powerful corporations or individuals, dominate the scene with unjust power structures. Or perhaps you picture sprawling cities filled with skyscrapers and flying cars, shrouded in perpetual darkness. And maybe the future seems bleak, where only a privileged few have access to nature, while the rest struggle to make ends meet on a harsh planet. In the cyberpunk world, our planet is either on the brink of a disaster or has already fallen into complete ruin. The stories consistently revolve around dominance and control, whether it's between the rich and the poor, corporations and the market, or humans and the AI robots they create. Cyberpunk is all about systematic and oppressive inequality. It's also about a future where most humans live in a highly mechanized society that disconnects them from the rest of the natural world. In this potential future, all the amazing technologies we've created don't really improve the lives of most people. In fact, they make things worse. It's not all bad, though. Sci-fi can be more than just entertainment. It has a way of inspiring and shaping our real world. Throughout history, designers have drawn inspiration from sci-fi for inventions for things like flip phones, self-driving cars, and even the concept of the metaverse. There are also many interesting alternatives for the future. Ever heard of solarpunk? It's also a genre of speculative fiction, but one that envisions technology and the environment evolving together. The solar part is all about the power of solar energy, while the punk part puts it in the same awesome group as other sci-fi genres like cyberpunk. So what does solarpunk actually look like? Well, imagine visually stunning utopias that are all about the environment and being positive. In solarpunk worlds, they've totally sorted out how to correctly use the planet's resources, or are actively working together to fix it. It's all about coming together and being friends in the fight against a bleak future. When you enter a solarpunk universe, you'll be greeted by groovy green tech, cities that are super walkable, and tons of lush greenery. It's all about living in harmony with nature, while still rocking the latest technology. It's like the complete opposite of cyberpunk, which is all about grimy cities, greedy corporations, and fear of outsiders. Solarpunk is all about putting people first and recognizing the amazing connection between human intelligence and the Earth. One of the major influences on solarpunk is Art Nouveau. This art movement is all about embracing organic and earthly shapes, and it fits perfectly with solarpunk's vibe. Another cool reference for solarpunk is the arts and crafts movement from the late 19th century. It was all about rebelling against unnecessary waste.
Have you ever wondered how cool buildings of the future are going to look? Well, hold on tight because artificial intelligence is here to revolutionize the world of architecture. AI is a great sidekick. It can give the architects incredible new tools to create mind-blowing structures that are not only stunning, but also eco-friendly and super efficient. So let's check what our beautiful future might look like. First of all, you know how cities can get crazy busy and overwhelming, right? Well, guess what? AI is here to save the day and make our cities super smart. Imagine you're cruising down the road in your flying car. Yes, we'll have those. Thanks to AI, the traffic flows like a dream. No more endless gridlock. The city knows where the most likely crime spots are and takes proactive steps to keep us safe. It's like having superheroes on every corner. And hey, forget about trash piling up. AI makes sure waste is managed efficiently, keeping our city clean and fresh. They can act as a city manager who can optimize everything from traffic to safety and even waste disposal. They can analyze tons of data from all sorts of places like sensors and social media. With all that information, they can help city planners make brilliant decisions that make our lives better. Okay, so you stroll down the street, and your eyes are instantly captivated by an extraordinary building. Its futuristic curves and features make it stand out from the rest. And it not only catches your eye, but also gives Mother Nature a high five. You might think it was designed by a genius architect, but little do you know it was actually a collaboration between humans and artificial intelligence. Imagine having a super smart design buddy who can whip up thousands of incredible building ideas in a blink of an eye. That's what AI-assisted design software does for architects. It can generate and assess a ton of design options. They take into account stuff like the best materials to use and the perfect placement for the building. Also, by analyzing data and crunching numbers, algorithms can help optimize the building's design. They can ensure it minimizes energy usage, conserves water, and manages waste like a pro. Every building strives to reduce costs, save energy, and promote a better world. The result? Architectural masterpieces that are both jaw-droppingly beautiful and super practical. The cityscape of the future will be dotted with these awe-inspiring structures. Oh, but that wasn't impressive enough for you? Well, how about a stunning, futuristic building that seems to defy gravity? It's not made of traditional bricks and mortar, oh no. This marvel was created using the powers of 3D printing. With the help of AI, architects designed every intricate detail and fed all the important data, like what materials to use and how the site conditions might affect the structure. AI algorithms worked their magic to optimize the design, making it both breathtakingly beautiful and rock solid. 3D printing is basically like having a magical machine that can create awesome structures straight out of a sci-fi movie, and AI jumps in to make sure these structures are not just pretty, but also strong. In the city of the future, 3D printing will become the ultimate architect's tool. It will allow them to create structures that were once impossible to build. From mind-bending shapes to intricate details, the possibilities are endless. But AI isn't just making buildings look great, it also makes them efficient and cozy. Let's say you step into a futuristic office building, and voila! The lights automatically adjust to match your mood, and the temperature is set perfectly for you. These futuristic buildings are capable of sensing and responding to their surroundings, just like you do. They control the lighting, keeping it just right for the time of day. They manage the temperature, so it's always cozy and comfortable. They even keep a watchful eye on security and fix small issues before they become big headaches. So, the smart building knows when people come and go, so it optimizes energy usage accordingly, saving the planet and some cash along the way. Now the cool thing is, all these aren't the only possibilities. How about turning skyscrapers into a vertical forest? Recently, an architect from India got super excited about the power of artificial intelligence. So, he decided to team up with an image bot called Midjourney to create a vision for the future. But instead of a dull, robotic world, they aimed for something spectacular. With text prompts like utopian technology and futuristic towers, the architect and AI got to work. Guess what? Midjourney didn't disappoint. It conjured up a world where buildings were covered in lush vertical forests and adorned with shapes inspired by nature. They wanted to create a sustainable future that harmonized with the environment. The architect, Manas Bhatia, is super positive about AI's potential. He doesn't see it as a threat to his job, but as a powerful tool for positive change. He envisions a future where architects and AI collaborate to make breathtaking designs. In his project, Bhatia even asked the AI to imagine symbiotic and hollowed structures, and it responded with pictures of apartments nestled within hollowed-out trees. Imagine a world where the building itself becomes a living, breathing part of nature. Well, Bhatia believes that nature should play a big role in architecture. He loves designing structures that embrace nature's beauty and functionality. From buildings built around trees to facades that regulate temperature, he's all about blending architecture with the natural world. With architects like Bhatia and the superpowers of AI, the future of cities is going to be amazing. So get ready to step into a world where nature and technology coexist in perfect harmony. It's a dream we can't wait to see come true. Or, if you're not a big fan of trees, how about this? Skyscrapers that aren't made of solid bricks, but instead, they're inflatable wonders. Zumo, an architectural practice in Barcelona, used the magic of AI to bring these wobbly structures to life. These inflatable superstructures rise above future cities like illuminated balloons in the sky. Here's the best part. These inflatable buildings have sustainability superpowers. You can pump them up to towering heights, flatten them for easy transportation, and rebuild them wherever they're needed. Plus, they're powered by renewable energy, reducing their impact on the environment. Pretty cool, right? Phew, the future is zooming toward us like a rocket. Artificial intelligence can become the secret sauce that makes architects' work extra special. But hey, with great power comes great responsibility. We need to use AI wisely and ethically. For now, we don't have to worry about machines replacing architects. Artificial intelligence still needs a human hand, or else we might end up with buildings that look like mashed up bananas or ice cream cones, unless that's your thing. In addition, humans have one important advantage. They, well, are humans. We need to keep in mind that artificial intelligence doesn't have emotional intelligence. It's a brainy genius, but it can't fully understand the feelings and vibes we humans crave in our spaces. So, we must remember to infuse our designs with that human touch, those warm and fuzzy elements that make us go, "Ah, I feel right at home." And let's not forget that AI is still learning. It's basically just taking its first steps, and we need to be patient and give it time to grow. Rushing things too quickly could lead to wonky designs or buildings that look like a jumbled puzzle. This might look cool if you like avant-garde architecture, but for regular folk, no thanks. So, as the future unfolds at warp speed, let's embrace the wonders of AI in architecture. But let's also remember to balance its brilliance with our own human touch. Together, we can create a future where buildings are not just functional, but also filled with heart and soul. It's an adventure that's out of this world.
This explosion is the brightest and most powerful in the history of our entire universe. And it was the start of absolutely everything. A Big Bang that happened 13.8 billion years ago. Elementary particles began to spread out in different directions and cool down into matter. This is the building material for the future universe. All the galaxies, black holes, stars, planets, asteroids, and even you and me. Yes, we're all created from the same set of particles that appeared at the Big Bang. A quick jump to 4.6 billion years ago. This is the nebula that's about to become our solar system. It's just a cloud of cosmic dust, rocks, and blocks of ice. Shock waves from supernovas from different directions around this place begin to push matter into a common center, just like sea waves. At one moment, all this matter begins to shrink around a center of gravity into one giant boulder. It attracts more and more other debris to itself. It presses on its own center so hard that nuclear reactions start there. A little more pressure and let there be light. And that's how our sun was born. 4.59 million years ago. This is when the first gas giant planets, Jupiter, Saturn, Uranus, and Neptune, are formed. They're composed entirely of gas and have no solid surface. Some say there was a fifth gas giant, but it was ejected outside the solar system. For another 100 million years, there's a solar nebula, a bright young star in the center, and a disc-shaped pile of gas and dust around it. These are remnants of matter from the original nebula. It's more like a boiling soup. The ingredients swirl around the sun, stirring and colliding with each other. They form the rest of the planets and moons of our solar system. When the dust settles, we can see Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, and Neptune. 4.5 billion years ago, while Earth is still a red-hot lump of rock and lava, Theia appears on the horizon. It's a protoplanet the size of Mars. It's formed close to Earth and is now flying toward it. Theia shatters into pieces and rips out a large chunk of our planet. A lot of debris is left in Earth's orbit and begins to come together. This is how the Moon was born. 4.1 to 3.8 billion years ago. This is the late heavy bombardment period. The remnants of debris that didn't become planets continue to travel through the solar system. They hit the gravitational fields of the freshly born planets and fall on them. Because of this event, we can see so many craters on Mercury and the Moon. Scientists have found the remnants of the oldest microorganisms in the world. They're about 3.8 billion years old. So, they were born around the time when the chaos of ever-falling meteorites ended. The process of evolution began. 3 billion years ago, strong solar winds and frequent meteorite impacts on Mars deprived it of its atmosphere. The atmosphere protected Mars from solar radiation, and now life can't be born there, although some scientists say that Mars was once inhabited. 2.5 billion years ago, an oxygen disaster is happening on Earth. Some organisms evolved to feed on the sun's energy and produce oxygen. Our atmosphere began to fill with it, and this washed away almost all pre-existing life forms. But it did pave the way for new ones. 100 million years ago, one of Saturn's moons was destroyed, either by a collision with a large asteroid or by the planet itself. The moon's debris began rapidly orbiting the planet and colliding with each other and turning into small rocks and dust. Most of this debris consisted of ice, and they remain to circle Saturn to this day. You can see it as rings near the planet. 66 million years ago, Earth suffers the impact of an asteroid the size of Manhattan. The blast waves from the impact can be seen from space. The ash cloud then completely covered the Earth and blocked the sun's rays. As a result of this event, most living organisms, including dinosaurs, ceased to exist. 70,000 years ago, let's look at the edge of the solar system. There's an area of asteroids and blocks of ice, the Oort cloud. And there's a rogue double star system approaching it. It pulls the asteroids out of the Oort cloud and throws them in our direction like a slingshot. Fortunately, the star passed by the solar system, but promised to return. 356 years ago. This is the date of the first discovery of the Great Red Spot on Jupiter. It's the source of strong winds on the planet, with speeds like the fastest supercars. If you compare this spot to the planet Earth, the spot is 30% bigger. Present time. The solar system looks exactly the same now as it did a few billion years ago, but humanity has added some new objects. You can see many artificial satellites and a vast international space station. Even on Mars, there are several rovers we sent there. Now let's look to the future. In the next few decades, Earth will constantly send spaceships to Mars. Every 2 years, when the distance between the planets is shortest, you may see an entire fleet of ships speeding toward the red planet. 100,000 years from now, the rogue star returns to the solar system. It disturbs the Oort cloud again and flies away. In 9 million years, it'll approach a record close distance of 52,000 Earth-Sun distances. 10 million years from now, Mars's moon, Phobos, has been steadily approaching the planet by 6 feet every 100 years. Gravitational interaction will first tear it apart. Some of the debris will fall on the red planet. Others will remain in its orbit in the shape of rings, just like Saturn's. The future of the solar system depends entirely on the sun. Every 1.1 billion years, its luminosity increases by 10%. This is because, over time, it'll burn more and more hydrogen fuel and get hotter. 1 billion years from now, Earth's temperature will become so high that liquid water will no longer exist. The oceans will evaporate, creating a greenhouse effect that will heat up the Earth even more. The existence of life here will become impossible. At this point, we see an entire fleet of ships flying toward Mars. These were the last inhabitants of Earth. As a result of the sun's increasing brightness and temperature, its habitable zone, that sweet spot for life in the solar system, has moved farther away from the star. Mars is now much warmer. The ice beneath its soil became liquid and evaporated, creating a greenhouse effect. Now the conditions on Mars are perfect for humans. 3.5 billion years from now, Earth now looks like modern-day Venus. It's filled with lifeless landscapes, with volcanoes and dry riverbeds. 7.7 billion years from now, the sun's hot core triggers nuclear reactions in the outer shell. As a result, the sun begins to expand and becomes a red giant. The star will increase 256 times in size. It'll literally swallow the nearby planets, Mercury and Venus. While the sun is insanely burning fuel, it's losing weight, and its gravity is weakening. This means that it no longer holds all the planets together as much, and their orbits expand slightly. So there's a chance that Earth will remain intact and will now be the first planet near the sun. Mars has gotten too hot for humans too, and we're making another distant migration, this time to Saturn's satellite, Titan. This is the only place in our solar system where water in liquid form has been proven to exist besides Earth. Conditions here should now be suitable to welcome humanity home. When the sun uses up a little more than half its fuel, it'll begin to shrink to a size 11 times larger than today. But in another 100 million years, it'll become a red giant again for the last time. After that, in another 30 million years, the star will begin to eject strong solar winds and stellar matter. There will now be a beautiful planetary nebula, which consists of the former outer shell of the Sun. The star will lose most of its weight, which means it'll no longer be able to hold the orbits of the planets. Chaos begins in the solar system. Some planets leave the borders of our world, others collide with each other, but some of them will be able to stay here, but in a more distant orbit. And in 75,000 years, only a white dwarf the size of the planet Earth will remain in the center of the solar system. The Sun will gradually cool until it fades away completely. If there are still planets left, they will be cold and dark, incapable of supporting any form of life. From its birth to the end, the entire history of the Sun will take about 12.4 billion years. Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our Sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our Sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. Most hydrogen in Sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our Sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the Sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The Sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The Sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the Sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets, enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. it'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. more and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone.
These days, you're better off boarding a plane if you want to travel from New York to London. But what if I told you there was a time when these two cities were actually on the same continent? Well, the explanation is a bit more complex. For starters, back then, these two cities didn't even exist at all. But the tectonic plates they sit on today were a lot closer. Nearly 200 million years ago, all of the continents on our planet connected, making up one large supercontinent. This enormous piece of land was surrounded by one single ocean. We call this huge continent Pangaea these days. Some parts of this continent broke apart and shifted away from each other for our maps to reach their current configuration. There's even a nice experiment you can conduct to test this theory. Find a map online and print it on a piece of paper. After that, simply cut out all of the continents. Once you start playing around with them, you'll soon notice they all seem to fit together, like pieces from a puzzle. Probably the most striking thing you'll see is how South America perfectly fits Africa. What's even more fascinating is that this isn't the first time in our planet's history that supercontinents have been formed and then broken apart. Scientists have figured out that this happened at least 3 times before. And if we consider our planet's age, 4.5 billion years, the last 200 million is closer to the blink of an eye. So how did scientists figure out that continents move? Apart from the aspect of today's continents, they also looked at identical rocks, which have been found on different continents. They looked like they formed from the same minerals and under the same weather conditions. Some other secret helpers? Well, dinosaurs. Fossils from the same species have been stumbled upon in both South America and Africa. This particular dinosaur, named Mesosaurus, is said to have lived on our planet way before the continents drifted apart. It's hard to imagine how life on Earth must have been with one single continent. For starters, the climate must have been very different. That's because the mid-portion of the land would have probably been bone dry, having little to no source of water. More so, it was most likely hidden away behind many mountain chains. These would have acted as a barrier against moisture and rainfall too. However, geologists have also studied coal deposits from the United States and Europe. These seem to show that at least a part of the ancient supercontinent, which was close to the equator, must have been an amazing tropical rainforest, just like those we can find in the Amazonian jungle today. Coal appears when remnants of plants and animals get stuck into swampy water. If enough pressure is applied by the water, the substance is first turned into peat, then into coal. Our planet existed in this continental configuration for over 100 million years, and during this time, there was a lot of life on Earth already thriving. Hey, it was a great time to be an insect. Critters like beetles and dragonflies flourished. During the same time period, the Earth was roamed by the predecessor of all mammals, the synapsid. Life in Pangaea was severely hit during one not-so-great period. It's believed that a comet or asteroid landed on the surface of the Earth about 251 million years ago. The asteroid or comet theory seems to fit pretty well, because 90% of all marine animals and 70% of the creatures living on land disappeared all of a sudden. The comet might not have been the only reason for the mass extinction. At the same time, there was also some important volcanic activity happening in northern Asia, which might have disrupted life on Earth. We may not notice it, but continents do continue moving as we speak. This configuration we now see with the help of satellite imagery will surely not be the last. Australia, for example, is slowly moving towards Asia. But the most important proof that our continents are still shifting is the eastern portion of Africa. This area is simply breaking off from the rest of the land. To witness this, you'll have to travel to one of the hottest places on our planet. But if you get to this piece of land on the eastern part of the African continent, you might sit on top of the exact spot that, soon enough, will be split in two by water. Underneath this region, 3 tectonic plates are slowly drifting apart. If the data is correct, in the far future, Africa will be split in 2, and between its 2 regions, a new ocean will arise. To support this theory, scientists have been closely studying a 35-mile-long crack in the Ethiopian desert for years. For this new ocean to form, it's estimated that 5 to 10 million years need to pass. Since our planet's crust is made out of multiple tectonic plates that are constantly moving, it's the perfect place to study this process. These plates are all irregularly shaped, and they are always mashing against, sliding under, or over each other. Those 3 tectonic plates found under the desert are also moving at different speeds. One of them, called the Arabian Plate, is sliding away from Africa at a speed of about 1 inch per year. The other 2 plates are moving a bit slower, somewhere between half an inch to 0.2 inches each year. More so, as these movements happen, material from deep inside Earth climbs to the surface and forms an oceanic crust at the edges. All this movement does make you wonder, how will the next supercontinent form, and when? So far, scientists came up with some possible configurations, each with its own name: Novo Pangea, Pangea Ultima, or Amasia. All these predictions still vary, as we're not sure how and why continents really move over time. One clue may be actually looking at how Pangea separated in the first place. Regardless, it will take anywhere from 15 to 100 million years to see the next future continent, depending on each scenario. Novo Pangea looks at the possibility in which present-day movements continue. In this scenario, the Atlantic Ocean will continue to expand, all the while making the Pacific smaller. The 2 American continents would first combine northward. Africa, Europe, and Asia will have already combined too, by the time they all meet together in one single huge piece of land. Another possible scenario is called Pangea Ultima. In this case, the Atlantic will slow down in its expansion and actually become a landlocked body of water. North America, Africa, Asia, and Europe would become somewhat parallel pieces of land, completely sewn together. Underneath them, South America, Antarctica, and Australia would complete the circle surrounding the North Atlantic. All the while, this piece of land would be surrounded by a large Pacific Ocean. Amasia looks at a scenario that's a bit difficult to understand and study at this point. Since several tectonic plates look like they are moving north, it might be possible that all continents, apart from Antarctica, will slide completely toward the North Pole. The climate would be a lot different and way colder. Both the Pacific and the Atlantic, in this scenario, would remain open bodies of water. Scientists believe this to be a real possibility because of some anomalies left by Pangea deep in the Earth's interior in the part called the mantle. Looking even further into our planet's future, it's estimated that in about 1 billion years, the luminosity of the sun will be somewhere around 10% higher. As such, the atmosphere on Earth will closely resemble that of a moist greenhouse. Because of the added heat, all the bodies of water on our planet will start to rapidly evaporate. Moving further to 4 billion years from now, the temperature on our planet will soon transform it into a Venus look-alike. It might get so hot that the Earth's surface will begin to melt away.
Okay, so you've seen the movies and read the books on time travel. Most of them tell stories about entering some futuristic boxes, and in the blink of an eye, you're in some different epoch. For now, this is just sci-fi. But there are ways to make time travel possible, at least theoretically. We just don't have the technology figured out yet. For starters, time travel to the future could be achieved by traveling at high speeds, but not just getting a ticket on the superhighway kind of speed. This is based on Einstein's theory of special relativity. It explains that time slows down for objects that move at really high speeds. And the good news is scientists have already tested this theory, and it looks promising. They did it with the help of two identical clocks. One was placed on a jet, and one stayed on the ground. They found that the clock on the jet ticked slower than the one on the ground because of how fast the jet was moving. The faster an object is moving, the more time will slow down for it. Currently, the fastest speeds achieved by human technology are seen in a special type of particles called neutrinos. Some of these can move at almost the speed of light. At these speeds, 1 second for the protons is equal to 11 months for us. Now, we might be able to time travel to the future with the use of gravity, too. This idea is based on Einstein's findings, namely his theory of general relativity. Now, this theory explains that the stronger gravity is, the more slowly time moves. This means that as you get closer to the center of the Earth, the strength of gravity increases. And if you think about it like that, time actually passes more slowly for your feet than for your head. Now, is that why I'm always late for stuff? Good excuse. This effect has been measured too, with the help of the same strategy with two identical clocks. Scientists placed them on shelves at different heights and measured the rate of ticking. The clock on the lower shelf ticked more slowly because it experienced a slightly stronger gravity. But this option comes with a catch. To be able to travel to the far future, you'll need to find a place with extremely strong gravity, like a black hole. That's a point in space where the gravity has so much force that even light cannot escape it. There, gravity becomes so intense that matter gets squeezed into a tiny space. The closer you get to the black hole, the more slowly time moves. However, traveling via a black hole is very dangerous, mostly because it's a one-way ticket. Once you cross its edges, there's no coming back. Now, here's a fun fact. The GPS systems we use on our phones and in our cars already have to account for time dilation effects in order to work properly. That's because of the speed of the satellites they use and the gravity they feel here on Earth. Without these corrections, your phone's GPS wouldn't be able to pinpoint your location on Earth very precisely. Meanwhile, the third option has less to do with the universe's unknown forces and more to do with our own bodies. Scientists are trying to find ways to time travel to the future by slowing down the body's own processes. It's not time travel per se. You wouldn't technically be going anywhere. But if your body stays put for a long period of time, you could eventually wake up in the future. Some animals, like bears and squirrels, can slow down their metabolism during hibernation, which means they don't need as much food and oxygen to survive. Specialists are trying to figure out if humans can do the same thing. They're working on ways to make people go into a short-term hibernation for a few hours to begin with. This could be helpful for medical emergencies too, in order to help a person before they can safely get to the hospital. In 2005, scientists were able to slow down the metabolism of mice by exposing them to a small amount of special gas. However, when they tried to do the same thing with larger animals, it did not work as effectively. Our fourth option of traveling through time is really unique. It involves a special type of shortcuts that may exist in our universe called wormholes. Now, before we move on, let's try to understand what they are. You'll need to picture two balls and a trampoline. If there's no pressure applied on the trampoline, it stays flat. Now imagine the two balls placed on the trampoline symmetrically. If you look at them from this perspective, there's no possibility of them ever touching. But if you put enough pressure on the trampoline between the two balls, this flexible fabric can stretch so much that the two objects might potentially touch each other. The same thing happens with stars in different star systems. They're big enough to curve space around them. That's why most planets tend to orbit around a star. The tunnel between those 2 points would be a wormhole. These wormholes could be used to travel long distances, like 1 billion light years, or even visit different times. Now, many scientists, like Stephen Hawking, think that wormholes might appear and disappear, but be very small, smaller than atoms. The problem is that we don't know how to catch one and make it bigger so that people can use it. This would take a lot of energy, and we don't know if it's even possible. Some astronomers say that even if we could find a wormhole and enter it, it would rapidly collapse on itself. Even the tiniest bit of extra mass, like that of our bodies for example, can result in the wormhole slamming shut, like a rubber band that's been stretched too much. Now, the fifth solution for time traveling was proposed by an American physicist named Ron Mallett. It involves one resource that we know for sure is abundant in the universe – light. The scientist proposed a theory about time travel that would use a rotating cylinder of light. He believes that if something was dropped inside this swirling cylinder, it could be moved in both space and time, similar to how a bubble moves when you swirl it with a spoon in your coffee. According to Mallett, the right shape of the cylinder could allow for traveling to both the past and the future. The physicist has been trying to raise money for an experiment to test his theory. This experiment involves dropping tiny particles, called neutrons, through a circular arrangement of spinning lasers. However, other scientists say Mallett's theory is impossible and there's no need to test it further. Well, even if we eventually figured out a way to travel back in the past or to the future, would it be safe? Scientists have been talking about a problem called the paradox of time travel for a long time. The main question is what would happen if you went back in time and did something that changed the future. However, a new study from researchers from the University of Queensland says that this problem might not be real after all. The scientists have done some calculations and found out that even if you had changed something in the past, the timeline would still end up the same way. Another variation of this problem is called the grandfather paradox. Imagine going back in time and preventing your own grandfather from having offspring. Come to think of it, it automatically means you shouldn't exist in the first place. If your grandparents didn't have your parents, how can you exist at all? Well, these days scientists are certain that even if you did experience something like that, you'd still exist in the present. That's because the timeline that already exists has a way of adjusting itself, regardless of where people are in time and what they do. Or somehow get 1.21 gigawatts in a DeLorean and make like Marty McFly.